Counselor, Dr. L. Parthasarathy, whose valuable advice paved way for the successful organizing of this event. We welcome you, sir. I also extend my welcome to the faculty and heads of various departments who have extended sincere support to the webinar. I cordially welcome all the participants of ATME CE for this webinar.
Thank you, Pooja, for welcoming the gathering. Now I request Lakshmi K, Assistant Professor, Department of IEEE, to give a brief introduction about today's speaker, Narayan Subramanian sir.
Good evening all. It's my privilege to introduce today's speaker, Mr. Narayanan Subramanian, to the audience. Mr. Narayanan Subramanian has 26 plus years in technology leadership, spanning electric vehicles, networking, telecommunications, data center infrastructure, and cloud services. Mr. Narayanan Subramanian is a mentor and public speaker on key technology developments, innovations, and disruptions. His professional experience includes under Cisco, technology leadership in the development of the serviceability platform for next generation DevOps enabled WebEx teams, the global market leader for cloud-based video voice conferencing. Under Dell, technology leadership in the development of the ID rack embedded data center server controller with web services and industry first. Under IBM, software engineer for the world's first 10-channel DWDM optical multiplexer network management offering, and many more. Thank you for accepting our invitation as the resource person, sir. Welcome you, sir.
Good evening, sir. So I request Narayan Subramanian sir to start the session.
Sure. Thank you very much. I hope I am audible.
Yes, sir, you are audible.
Okay. So thank you very much to the faculty and students of ATME College of Engineering. I am very honored to be here. Thank you for having me over. And I hope I'll be able to share some insights and some learnings that I have. I hope I'll be able to share some learning and insights over the next hour and a half or so. And I'm really delighted that the student body has got together with the faculty to explore areas more specifically related to clean and green energy technologies, sustainable development, and so on. They are all kind of interrelated with each other. So let me just open my share. Just give me 1 second, please, as I bring up. 1 minute. Able to see my share? Can somebody confirm that you can see it?
Yes, sir. It is possible. Yeah.
Wonderful. Okay. So I think the topic for today. So as I was contacted by Dr. Sujata, student activities, was to talk about clean energy and sustainable development and topics like that, right? So what I thought I would do was to give a quick about 2 areas. The first thing was around the need for clean energy. What are the options available today with technologies that we have today? Before that, to give a very quick, usually this talk of mine is probably about over 2.5 hours. So I would give a very quick overview on why we look towards clean energy technologies, what are the issues involved. Then I will give a broad sweep about that. And then, given that the audience is a lot interdisciplinary as well, I will talk a little bit about, based on my experience in electric mobility, a little more detail about project swapping status, IoT, software building block. Okay. And I think hopefully that would complement a lot of what Dr. Kiran, I think, would have talked to you on Wednesday. So let me just get started. So this there's a lot of background noise.
Sir, I have muted all the participants, sir.
Okay.
Yes.
I'm just hearing a lot of background. Okay. So this topic is very close to my own heart, right? So although I work in the IT field, I've predominantly been an IT person for the last 26 years. We're working on a variety of technologies, right? This sustainable development, preserving the environment, the natural world, and so on, are topics very close to my heart for a very long time, right? Ever since, I would say, childhood. I think sometimes I think I should have pursued a course in biology and ecology, what perhaps I would have been equally good at, but fate had me that I went into electrical engineering, and like many of you, and eventually ended up in the IT field for a long time. But anyways, it's now time to put all the experiences which I've had in this area for a long time, along with my own personal interests, and to try in my own small way, at least to communicate, to educate, and maybe work on some small projects which will help us preserving our natural environment, which we are so which we have a ethical responsibility. Okay. So let's a little precursor. Now, why is it that we are talking today about clean energy and sustainable environment, right? What's the real problem here? The problem really, if you look at it, and it's very intentionally, I kept the word sustainable environment, right? It clearly means that if we are talking about this subject, that means that we are probably doing something wrong, right? That means there are certain challenges today with regards to the environment and with regards to keeping it in a sustainable and healthy fashion. I think it's very apparent to us. Over the last 20, 30 years, you would have seen and heard every day in the news, you increasingly keep hearing about issues related to, species extinction, climate change, global warming, the warming of the planet, right? So these are things I think is very important, even as engineers, as technologists. It doesn't matter what branch of engineering you are in, truly in the of engineering where sustainability and preservation of the environment has to be key, front and center for every single engineer. It doesn't matter whether you're in computer science, in electrical engineering, in mechanical, civil, it does not matter anymore, right? I think this is something that needs to be front and center for everybody to think about, evaluate, and consciously work towards. Right? So what is it that I'm talking about? Right? So I'm going to skim through this rather quickly. I'm not going to spend too much time in a deep dive, given the time constraint and all the topics that I need to. The first thing is, it's very for you as students. You are the young generation, and I view you as torch bearers, right? To help restore, at least to some extent, our natural environment and world, right? And the primary causes for its degradation, whichever way you look at it, it's actually the human population. Okay. Finally, whatever that you do, I spent many years thinking about this, reading so many articles and reflecting on this, and I cannot come to any other conclusion, right? As a student of science and as a student of technology, and a lot of this has got to do with our population growth and the amount of stress that we put on the environment related to food, water, energy, space, and shelter. Right? When I was born, population was probably just around 3 billion people. This is in the late 1960s. Today, we are at 7.5 or 7.8 billion, heading towards 10 billion, definitely in the next 30 years or so, if not sooner. Okay. And this puts a huge stress on resources on a finite planet. Now, this is the first fundamental thing that all of us need to understand. This is not a topic just for human sociologists or for political parties or politicians or government leaders or health leaders. This is a topic that everyone needs to understand, right? Including you as young budding engineers and technologists. It is primarily our responsibility why we are here at this point of time. And there is direct scientific correlation, right? So if you look, this phenomenon of climate change, because of which we are talking about sustainable environment, clean energy, electric vehicle, it's all interlinked, right? This is because this is our own man-made phenomenon, okay? And the reason why it is man-made is because we have incorporated an energy imbalance into the planet in the last 100 to 200 years since the advent of the Industrial Revolution. We have changed the energy of the planet. Human industrial activities, due to all these things which I talked about, more than what can be. And that is leading to global warming. That is leading to unnaturally fast change in climate. Climate has always changed. Please understand that. It has always changed over the 4.5 to 5 billion year history of the planet. It has always changed. The key here is unnatural, rapid change, which is completely unnatural due to man-made energy imbalance. This is why there's species extinction, and this is why even our geographical environment is also getting unnaturally landscaped. Rivers are drying up, river flows are changing, glaciers are melting. There is a change in the entire geographical environment as well as in the natural environment of flora and fauna, includes the animal kingdom and everything else. Okay, this is very, very important for us to acknowledge, accept, and understand. Right? When we talk of this, climate has always been changing. Yes, it has been naturally. There has been change in carbon dioxide. Naturally, there has been periods where extreme glaciation has been there. A lot of North America and Europe was all under glaciers, couple of kilometers thick, couple of 1,000 feet thick, right? In the ice ages. That is true. And they have melted, again glaciated. This is due to patterns of the Earth's orbit around the sun. There's something called the Milankovitch cycle. There is something known as the young sun paradox, right? As the sun is also maturing, there's more solar radiation, 0.4% more than what there was a long time ago, right? All these cause warming and changes in climate. But the speed at which we have changed the climate now in the last 100 years or last 50 or 30 years has been unnatural. And this is directly correlated to the graph and greenhouse gas emissions. This is unnatural. You can always see that in the last million years over glaciation periods, there has been variation. But this peak, right, from 280 parts per million to today's value, which is about close to 415 parts per million, is unnatural. It has never been seen before, right? And at this speed, because nature cannot adapt. Okay, this is the key point. Nature is unable to adapt due to the rapidity with which we are generating all these greenhouse gases, right? And this is directly correlated with human activity and human population growth. Okay. Now, many of you are physics students. Hopefully, you haven't forgotten first year, second year physics, right? There's a famous Stefan Boltzmann equation for thermal radiation. This is the thermal radiation from the sun. This is the long-range infrared radiation from the surface of the Earth, the one in blue. The one in red is the long wavelength overall radiation pattern from the sun, and the blue is the radiation pattern from the Earth. What I want you to take away from this is the following, right? There's a finite amount of energy which comes and impinges on the surface of the Earth. Okay, there's an equation and there's a bunch of physics which can explain, how many watts per meter squared is actually coming in. Right? Now, if you look at this graph is basically showing the absorption and scattering pattern for different types of radiation at various wavelengths, starting from the ultraviolet to long wavelength infrared. Okay. Now, a bulk of this is absorbed in the atmosphere by number of components. If you look at solar radiation, because of the presence of ozone specifically, UV gets absorbed, so that you can see this band here. Okay. Now, we have, our human biology has adapted to the visible light spectrum, right, of about 400 nanometers or so, primarily because, right, none of this is getting absorbed. And so our eyes, which are one of our sensors, okay, has beautifully adapted to this entire spectral range, right, due to biological evolution. And this is true of many species. Now, as you go further in wavelengths, as you go further in wavelengths, you will start seeing that water vapor is one of the most powerful greenhouse gases. But of course, it's water, right? I mean, there's a water cycle, so that cannot be avoided. Right? But as you go further and further, you will start seeing various other gases. You have carbon dioxide, you have methane, you have nitrous oxide. What is important to understand is these gases are commonly referred to. But what I want you to take away from this picture is this is the average band of infrared radiation from the surface of the Earth due to human activities. Right now, this portion in blue is what escapes back into the into space. But if you look at the side bands of this is possible at the side bands, and nitrous oxide absorption is also possible at the side band. So the more carbon dioxide we have, the more methane we have, the more nitrous oxide we have, this blue portion is going to shrink because we are going to eat at these side corners, which is the corresponds to the absorption spectrum of long wavelength radiation. Okay, so this is the part I want you to understand. So why, when we talk of greenhouse gas emission due to fossil fuel burning from vehicles, IC engines and so on, this is what we are referring to. As this absorption band increases over here on this side, right, less, this blue piece is going to get smaller and smaller, which means less radiation is going to go back out into space. What does that mean? It means that more is absorbed by these gases in the atmosphere and back radiated back to the surface. That is the net effect of greenhouse gas effect of global warming. Okay, so the more stuff we put that is in these bands, the more trouble we are going to get into. And this is why there is a push towards technologies that reduce these emissions in some form or shape, of which one is green energy, that is the electric space, the solar, the wind, and so on, which I'll come to in a minute. Okay, so I just wanted you to understand a little bit of the physics around this. I'm not going to spend too much time because we are a little constrained for time. This is the entire picture, right? There is incoming solar radiation. Some of it gets reflected out. Some of it is absorbed by the surface. Then there is human activities, right? And some of it goes out. And then here, the more we have water vapor, you cannot escape. But the more you have carbon dioxide, methane, nitrous oxide, and so on, the more stuff is going to get absorbed and back radiated. Now, there are enough climate models. There's a 1-layer model, 2-layer model, 3-layer model. You can use equations related to emissivity of all these different layers and figure out that warming is going to happen over a period of time. Okay, they're fairly simple math equations and very simple models, very simple math. Beyond that, of course, a lot of it is done through modeling. The important thing I want you to understand also as students is, while we talk of greenhouse gases, carbon dioxide, methane, nitrous oxide, etc., not all of them behave equally. For the same unit of carbon dioxide and the same unit of methane behave very, very differently. This is another thing I want you to understand, because before you get into the appropriate green technologies, you should also take an evaluation of what is the entire life cycle to produce these technologies. And as while producing these green technologies, say we decide the process requires a lot of methane to be emitted, right? For example, methane has 23 times the destructive power with respect to warming compared to the same unit of carbon dioxide. That is expressed in something called GWP, which is the global warming potential. Okay, so for the same mass or same unit of methane has 23 times more global warming potential than the same amount of carbon dioxide. This is big trouble. Okay, and this is very important to understand, because although the quantity of carbon dioxide is, say, I think 420 parts per million, and methane might just be 2 parts per million, but the impact of methane is 23 times more than the impact of carbon dioxide for the same mass, okay, same unit volume. So it is very important to keep that in mind. Different types of things that we emit into the atmosphere or into the soil, all of these have global warming potential. The worst are the new sulfur hexafluorides, it is 22,000 times the global warming potential of carbon dioxide. Okay, so anything that we emit, although it might be in small quantity, it can cause a huge amount of impact vis-a-vis global warming, right? And which is leading to climate change and all the other stuff that we are familiar with. So please keep this in mind. So quick summary, okay, I'm sorry I'm going a little fast. Quick summary, there is a huge, and every student needs to understand this. Okay, I know that some of you may be doing humanities courses, economics and so on. Please pay very close attention. Please try and take some courses, related to geography, related to economics of sustainability, the economics of a green technology revolution. Some studies around that, because we are part of this natural world, right? Although we are engineers and technologists, it's not enough, in my opinion, that we know only Laplace and Fourier transforms, okay, or know Kirchhoff's laws and all this stuff, or signal processing theory or estimation theory or Kalman equation. That's not enough, right? We need to also have an equal appreciation of the humanities, right? And what areas I'm talking about, right? Is very important for us as engineers to solve these problems. We should have some basic understanding of what is the water cycle, what is the life cycle of soil, how does somebody farm, what are the challenges in farming, what is meant by waste management, what is the economics around this, what are the different know-how related to various societies in the world. India has a very rich culture, Africa has a very rich culture, very rich tribal cultures where people understand biodiversity very well. Right? So many things are there, right? And it's excellent for each one of you to also spend as much time as a university allows in humanities courses, right? To make good understanding and leverage of it. It will broaden your mind, and you will start thinking more holistically about your impact to society and your impact to the world. Okay, very, very important, please. And the reason why I bring this is there's a massive impact of climate change. It is not just it is getting hotter or I'm having water problem in Bangalore and Mysore. It is much bigger than that. Okay, it is much bigger than what you think the impact of COVID is. Okay, we are going through a pandemic right now. Okay, the impact of climate change, in my opinion, will at least be 1,000 times more than what you're seeing the impact of COVID. COVID, at least we can manage. Climate is a natural earth planetary phenomenon, very difficult to control, and we should not think that we can control it. We have to figure out a way to live in harmony with nature, else the impacts will be sea level rises. This is already happening in lots of countries. It is going to impact India the most, especially in the Bangladesh, Bengal areas, around the Chennai coast, around the Andhra coast, right? There's already sea level rise which is happening. And right now it is small, but it will go at exponential rate as the planet warms, okay? Every year it is growing at about a couple of millimeters a year, but it could very well go into many inches or centimeters per year if this acceleration continues. Okay, that will result in huge population displacement. Countries like Indonesia are already facing this. Nearly 60 million people are under threat of rising oceans. Okay, where will 60 million people go? They will all become climate refugees. Same thing in India. Okay, now increasing heat, and the heat is increasing because the radiation pattern is such that the lower latitudes are getting warmer much faster. Okay, and when the lower latitudes get warmer much faster, who are the countries in the lower latitudes? India, a bulk of Africa, and certain parts of the United States, right? And that is where you will see extreme drought, water shortage, and all these things, right? And water, the next fight will be for water. We already know water stress in big cities. This year, nobody is talking of water problem because we have not depleted the groundwater like what we did in previous years. And the only reason is because of COVID and because of our commercial reduction in commercial and industrial activity. Okay, diseases, lots of high temperature diseases, malaria, diphtheria, okay, cholera, all these things will rise even further. In United States, 20 years ago, nobody used to think of fogging, mosquito fogging. This now every year they are fogging in New York. A mosquito problem, right? Which is a huge for diseases, right? So all this also adds to food stress, right? Poverty, food stress, things which we are starting to see. Sometimes we think, okay, in Bangalore it is raining heavily, very nice climate, nothing is happening. What are people talking about global warming? Global warming is a phenomenon where the planet as an average is warming. As an average, average as an engineer, average is not a good number, right? That's why you have standard deviations. That's why you have other metrics, right? And that's why you have percentile curves. On the average, it is warming, but it means that certain places where there's rainfall today will have more rainfall. The upper latitudes may have cooler winters, while the earth in the mid latitudes, lower latitudes is warming abnormally, right? So on the average, it is increasing. Certain parts will have 5 to 8 degrees Celsius, not just 2 degrees Celsius warming, right? This is all devastating. Right? So please keep this context in mind. So the water, we know we're having water issues, right? Groundwater depletion. The ocean is also getting increasingly acidified. You don't see it like acid in your lab, like sulfuric acid or nitric acid, right? You don't see anything bubbling, but these are minute changes, right? Couple of points in the pH, decimal points in the pH scale can cause devastation. The entire food chain of the ocean depends upon microcarbonates, right? And plant foods and plankton and all these things, and increasing acidification destroys them. And once the food chain is destroyed, entire impact from the top smallest plankton to the biggest whale gets impacted. Okay, and ocean is a huge sink for carbon dioxide and energy from the earth, right? There's only a limit to which it can take. Soil is getting impacted. As I told you, temperatures will rise in the lower latitudes, right? So which means more evaporation, more tendency for drought. Now, due to our monoculture and due to our pesticide industrial related farming activities, right? There's a lot of loss of biodiversity and natural soil health. Right, microclimate of soils. I would encourage a university or maybe some of you go offline to understand what this really means, see some documentaries and so on. Right, it's everything is linked together. Okay, just having green energy and green technology without understanding all these things, we will not solve the larger problem. Okay, it's very important to understand. Also understand the importance of biodiversity. Why bees matter and all these things, right? Because 85% of entire flora in the planet, all plant species are pollinated by bees. So we benefit from agriculture, we benefit from our natural environment, right? So let's be very careful. Please be very careful next time you see a beehive and decide to go take some flames or cut the tree and all that stuff, right? Please don't do that, right? Please understand the larger purpose behind which nature has beautifully evolved and created this entire interdependence, right, of the natural environment. Right? I've talked about methane, right? It's a very powerful greenhouse gas. Glaciers are melting. So the more stuff you put out, the hotter it gets. The hotter it gets, things like the permafrost in Siberia or in the Canadian Arctic also will melt. What is permafrost? It hides below the thick layer of ice, about 40,000 years old of biological material, right? From the previous last inception of the ice age. That stuff will start decomposing, and I'm talking of millions of acres, right? And that results in more methane, more temperature rise, more melting, more methane, and this cycle goes on forever. Okay, so please assess all these things. And before I get into the technology aspects of it, the other huge impact of global warming is why you are seeing unnatural rainfalls, why you are seeing unnatural patterns which are happening, is because there is something known as a thermo-haline cycle of this planet, where water, in the oceans transport heat energy, right? With the increasing unnatural radiation patterns at the lower latitudes, there is more circulation, but also more melting of ice from Greenland and the Antarctic shelves. When that ice melts, it's not sea ice, it's fresh ice. When that ice melts, what happens is that the salinity of the ocean changes. When the salinity of the ocean changes, the density and the water cycle also change. When that changes, it will result in drastic changes in climate and in rainfall patterns and in heating. Okay, this is a huge imbalance which will happen with the melting of the polar sheets. Okay, the impact is on this thermo-haline cycle. Okay, so for more, you can go Google offline and read. Each one of these is an ocean of information that you need to understand. I just wanted to present to you snippets so that you get some perspective as to why we are even talking of this green energy. Okay. How is India impacted? India is one of the countries to be most impacted compared to any other place. We are a country of 1.4 billion people, right? We also have an ice cap, which is in the northern Himalayas, is the Tibetan plateau. Okay, that is where Brahmaputra comes from, where Sindhu, people call Indus River, comes from, right? A lot of the meltwater from Ganga comes from there, right? Let us not ignore that fact. If that piece melts, the entire northern India is in stress. Northern India is already in stress due to water depletion in Punjab, Haryana, Uttar Pradesh, and so many parts, right? And as technologists, we must understand, right? So as IEEE, I'm glad that IEEE is helping to sponsor this. As IEEE, there's a code of ethics. I will show it before we conclude. One of the key part, the first part in the code of ethics is to develop technology which is of value to humanity and done in a sustainable way. To quote David Attenborough, okay, one of the persons whom I look up very much, it's a great saying, we have a finite environment, which is our planet. If you think that you can have infinite growth, so this notion of sustainable growth, sometimes I don't know what that means, right? Growth, right? If you think that you can have infinite growth in a finite environment with finite resources, the person who thinks that is either an economist or a madman, in his words, right? We have to think holistically, end to end. You are the young budding engineers and technologists of tomorrow, right? My generation, my parents' generation, and maybe the generation before that, right? We have created the system of economics, of industrial growth, of consumption, which I think has been to some extent good, but also large extent a big mistake, perhaps one of the biggest mistakes in human history, right? Which has leading us to this situation. And it is you as young people whom I look forward to enabling and supporting in any way that I can to solve this problem. It is really the youth that is going to save us. That's you. And that's why I want to talk to you about this subject. Okay, so now what do we do, right? So part of this talk, I wanted to, of course, cover questions around green energy and so on. So let me jump into that, right? So one of these things is to leverage technology in terms of how we use it on our day-to-day activities, and some of it is related to non-polluting technology, which is the green technology. Okay, and this technology is used for all our daily activities, be it agriculture, lighting, cooking, and so on and so forth. So I'm just going to focus a little bit more towards that. Okay, and I'm going to leave the rest of the topics because we'll run short of time. Right? Now, this one thing I wanted to put this think of climate change or climate action and green energy in education. Education, unfortunately, I will not be able to talk anything much about it today. I briefly touched upon it, the need for you to understand humanities, need for you to understand farming, need for you to understand biodiversity, water cycle, all those things, geography. One of the worst taught subjects in schools is geography, but it's actually the most important subject if you look at it in today's context, right? So, please spend some time on that. So right now I will jump into the clean energy piece. Okay. So clean energy is, and this is a problem that we need to solve.
Hello, sir. So your mic has been muted. Sir, Narayan sir, your mic has been muted.
Yeah, you feel free to unmute me if in case it gets disconnected.
Yeah, sir. Sir, actually, you had exited the presentation, sir.
No, I'm going to bring it back because I was trying to search for this Microsoft Teams. I'll put it back in a second. One second.
Okay, sir. Okay.
Okay. In case I get muted accidentally for some reason, please unmute me. Okay, feel free. I think you have the privileges, right?
Yeah.
You should be having the permissions to unmute me in case. Otherwise, just let me know. No problem.
Okay, sir. Okay, sir. Okay.
I hope you didn't lose too much.
No, sir. No, sir.
Okay. All right. Let me. I don't know where you lost me. Is it here?
No, sir. Actually, you were describing about clean energy. So, yeah. Slide number 13, sir. Slide number 13.
About here?
13.
13. Okay, fine. So let me keep it at this so that then I can see everything also. I think this is visible to you, right?
Yeah, sir. Visible.
Okay. All right. So let me just keep it this way. Then at least I know what is going on. In case there's a problem later on, just let me know. All right.
Okay. Okay, sir.
So let me quickly go through. So clean energy, energy efficiency. It must be able to meet all kinds of requirements, right? And it should be at low cost, and it should be decentralized. I think this notion of having central huge power plants feeding huge areas may or may not make sense in the rural context when it comes to renewable energy going forward. Okay. So what are the different things, right? So I think I'm not sure if Ravi Kiran covered some of this, but let me go through this anyway, right? So solar grids is definitely something that people need to look at in communities, be it in semi-urban or rural communities, right? And the efficiency of solar panels has greatly increased, especially in the last 20 years or so, and it's become economically very feasible and very cost competitive in relation to coal and fossil fuels, right? Now, the important thing to note about solar energy is that, yes, while we have solar energy, it's equally important to have the battery backup systems, right? And this because for obvious reasons. I mean, solar is not available 24 hours a day, right? And you need to store that energy in battery backup systems, and so that they can supply the power during the night. Apart from this, very important considerations is a life cycle for battery and solar, right? Solar panels have to be maintained, batteries have to be maintained, and they also have to be recycled. Why I am bringing up these things is, yes, while solar grids, at different scales microgrid, picogrid, nanogrid. They are all at different scales, super useful and can provide power. We also have to think as engineers, right? And you young engineers, while you look at efficiency of photovoltaic, cells and so on, also look at how you can minimize the maintenance needed for solar panels, the life cycle of battery backup or secondary battery backed up systems, right? So that can supply power, as well as the recyclability of all these materials. See, after a point of time, even batteries, because of their chemistry, and of course photovoltaic systems because of their physics and chemistry.
Sir,
Yes,
Narayan sir, can you
yeah,
able to put it on slideshow mode, sir, so that we will get enlarged view, if you don't
yeah,
mind?
sure. Yes, is this better? Is it okay?
Yeah, sir, this is okay. Somewhat
Okay.
okay.
Yeah, I'm sorry about that. Okay, I
Okay, sir.
hope you can
Carry on,
read
sir.
the slide now.
Yeah, sir. Yes.
Okay, so very important for you to also focus on technologies, not just to increase the photovoltaic efficiency or the battery density capacity to store this energy. Also look at how easy technologies for easy maintenance of this. If the panel gets grime or panel gets a lot of dust, the efficiency drops, correct? Um, so the material science technology, okay, that you use is also becoming equally important. I don't know if we have material science engineers on this call, but if your university is offering these courses, you know these people, it's very important that these also be looked at, right? Apart from the basic physics and chemistry of the photovoltaic or batteries. The recycling is also important. So the technologies for this entire supply chain of these materials and the recycling of these materials to see how much can be repurposed without further polluting the environment. Right? There's no point in moving to all solar grids and after 10 years throwing them into a landfill and the whole place becomes toxic. Right? It's self-defeating. Okay, so we need to have the technologies that can take care of the entire life cycle. How much energy does it take to produce these technologies is also important, right? How much energy is required to produce solar cells and batteries? When we deploy it, how much of energy and water and other resources are required to maintain it? And then finally, when the life cycle is reaches to a point where the capacity is not high enough to generate electricity in a sustainable or scalable fashion, when they have to be recycled, how that will be taken care of, and what materials could be recovered from that. That 360-degree view is what I want each of you to start thinking of. It is not enough to just jump, buy a solar panel, do a project, do an experiment, and say I can do a light bulb or I can run fan or computer even at night. That is only 20% of the story. The rest of the story is around the entire life cycle for this as a solution and as a product. Okay. If you say that a lot of water is needed to clean these panels every day, where is that water going to come from? Right? At what cost? Human cost, right? Animal cost. So please think of it holistically. Okay, but solar grid definitely a way to go. Now, whether massive solar farms are best or not is open to debate. But at least I feel in small communities, these micro, nano, pico grids are extremely useful because they limit the impact on the rest of the environment in terms of resources needed to maintain clean and so on and so forth. Now, when it comes to wind, in my opinion, yes, wind is great when you have ocean-based or coastal-based, wind farms, right, where you have sufficient wind velocity. But of course, there is a danger limit also because many coastal or ocean areas experience extremely rough weather and conditions. You don't want these things flying away or breaking off somewhere. In the land context, I feel that the mix of hybrid and solar is what is very efficient. See, the problem with wind is the power is related to the cube of the wind velocity. So if the wind velocity reduces by half, power drops to 1/8. Okay, so that's the challenge, right? So that's why this mix of hybrid and solar, where one drops, the other picks up, right? Very hot days, sometimes there's no wind, so you use a solar. Then towards evening, less sunlight, wind picks up, so you kind of balance between the two. Irrespective of what you do, you still need the battery backup and the maintenance, okay? But if wind technology is being incorporated, please look at it from a hybrid perspective. Now, cooking, right? A lot of rural may not apply in urban India. The other two solutions apply in urban for sure. This one definitely will apply in semi-urban or rural areas. Is in terms of cooking gas, rather than transporting cylinders, millions of cylinders all over the place. I think in the agricultural context, which is a bulk of rural India, right? Biogas is definitely an extremely sustainable and viable method for recycling of animal manure, for generation of methane for cooking purposes, fairly clean, and excellent substitute for firewood, which would otherwise be cut and the forests get depleted over a period of time, right, as human population grows. So these are projects which I think if you guys are doing or want to study more, I encourage, right, all three to go ahead and do it. Now I wanted to cover on electric mobility a little more, right? So they are, I think, so did Ravi Kiran cover, to what extent did he cover that day? If one of you.
Yeah, sir. I would like to give insights about Ravi Kiran's presentation.
Yes.
Sir has covered about electric vehicles and design and charging station a little bit. And more aspects, sir has given about the different modes of charging methods, AC and DC, and wireless. And about the battery design, little bit sir has covered, sir.
Okay, all right. So I will cover other different aspects. Okay.
Okay, sir. Thank you.
So I think the need to go to electric mobility is not just because it is not generating fumes like carbon monoxide, carbon dioxide, and nitrous oxide, and all that while the vehicle is driving. The need to push for electric mobility is simply because it is efficient. Okay, it is 6 times more efficient per unit energy as compared to fossil fuel today. Okay. And when I talk of electric mobility, I want to make the distinction. The car is driven by electric motors. Okay, so electric powertrain and drivetrain is all that is fine. When I talk of electric mobility, I'm not just talking about battery-based mobility. It could be hydrogen fuel cell powered. It could be this aluminum air. It could be lithium-ion based. There is some electrical source of electrical power which drives an electric powertrain, which is what is very efficient. Okay, so please don't constrain yourself in thinking that only lithium-ion based solutions are the only things to go look at. Okay, they could very well be any other form or source of electrical power. Right, and once you have that source of electrical power, as long as it can be generated in a safe and sustainable way, driving an electric powertrain is at least 5 to 6 times more efficient than from a fossil fuel engine. Okay. Now there are different things. There are different types of technologies, right? And there are so many factors to consider. Okay. Now there is, I think in India, from a rural context, 2-wheelers, 3-wheelers, farm equipment, I think there is huge scope for electric mobility and the adoption of this technology. In cities, definitely electric buses. We have metros which are obviously electric, but in terms of transportation, electric buses, apart from scooters, rickshaws and 2-wheelers. I am intentionally not including electric cars. I do not believe that India really needs or will benefit from an electric car revolution. I think we need to solve the problems for the mass population of this country, which still uses scooters and 2-wheelers, okay, and 3-wheelers, and lots of people use buses. I think that mass transportation and these other modes of transportation requirements are things that we need to focus on. I think electric cars can come in, but perhaps come in a little later. This is my personal viewpoint. Okay, so others may feel differently, but I think that our focus needs to be on this and on farm equipment. Okay, now each of these types of equipment have different types of usage, right? 2-wheeler, 3-wheeler, electric drain, power drain is different from how a farm equipment would be, right? And so based on that, you'll have to evaluate different types of technology. Okay. Now, there are essentially two types of technology. Now, if I focus on this lithium-ion based solutions, right, which is the most prevalent one for electric mobility today, right? There are two types. One is fixed battery, and the other is battery swap or charge. Now, in fixed battery, right? I have intentionally put this voltage, charge, current curves here, right, and the charge capacity, because it's not a linear graph, right? There's a period of time where you charge the battery, using constant current, and when it builds up capacity, right, when the voltage, cell voltage goes up to nearly 100%, then you do it at a constant voltage and reducing current, right? And that is why it takes significantly longer than what you would anticipate. It's because of this curve profile, right? So in a electric mobility, from that standpoint, right? Now, two-wheelers, three-wheelers, they have different capacities of batteries, right? Usually, two-wheelers, three-wheelers, you have 2 kilowatt-hour battery to 3 kilowatt, not more than that, right? And it takes a couple of hours for you to charge that. When you go to higher form factor vehicles like tractors and so on, their energy density for their batteries is much higher, maybe at least 15 kilowatt-hour batteries, if not more, right? So fixed battery solution means what? You have to go and plug your stuff, your vehicle in somewhere, and it gets charged according to this charge profile. Okay, similar to this charge profile, right? Now, it is good. It is good when you have a limited use of the vehicle and you have the ability to charge your vehicle at the end of the day for a couple of hours. So, in a rural context, I would suggest this is very appropriate for personal commute vehicles like two-wheelers and three-wheelers, not so relevant for farm equipment, having fixed battery solutions, because farm equipment draws a lot of power, right? Midway through the farming day, if you go and charge it for 2-3 hours, by the time the evening comes, right, and you've lost a lot of productive time, right? So whenever you're looking at technology, you also have to look at the use cases and what technology is appropriate to use based on the usage pattern, based of, like in this case, how long does it take to charge, what type of energy source you will have. Now, obviously, if you want to use completely go into green energy, this should also be charged using renewable power, right? So the question now comes in rural areas, where do you put this? There is no point in having coal-powered electric lines to charge this two-wheeler. So the question is now, can I charge this at my solar microgrid, where I have a couple of chargers? Can it give enough power during the day, to charge this, or at night, sufficient battery backup power to charge these vehicles when they're charging at night, right? So this is the plus and minus. So there's a lot of software that can be written to intelligently route power and to save power in all these microgrids, to also charge vehicles which are brought there as a common access point for charging. Now, battery swap. So battery swap is what? It's just like going to a petrol station today. Instead of tanking up for full tank of petrol, you are now taking out your old used battery and getting a new one from the vendor, right? It's as simple as that. And this type of profile is very good now for these farm equipment tractors who don't need these massive batteries, but can quickly go and replace the battery and come back, because they are heavy duty use. It may not be so viable for personal vehicles, because you don't travel that much during the day, and at night time it's mostly idle. So you don't really need replenishment, so the fixed battery is better. Okay. Yeah. So these are the essential two, but swappable comes with, I'm just oversimplifying it, right? Swappable comes with its own sets of plus and minus, right? And the life cycle of the batteries, there's a lot of shock and wind more than what you would associate with fixed battery solutions, because you keep taking in and out connector technologies. Then the same battery could be used in different form factor, could be used in a rickshaw this minute, after half an hour could be used in a two-wheeler, and so on, right? And each of which have different driving characteristics. So the battery is put through a lot more strain than what it is normally, right? So these are different types of technologies where electric mobility could be used. So I was heavily involved in developing this battery swap. These are the exact photos of the exact product that I worked on, right, in a previous startup, and which is now in deployment in certain cities in India. So it is a definitely viable product, but it has certain validity. In urban settings like in Delhi or Bangalore and so on, this is a great solution for two-wheelers, for three-wheelers, rickshaws and autos. And that's why this you will find increasing popularity where metro is heavily used for last mile solutions, because there's a lot of usage throughout the day and nobody has time to charge the vehicle. So it's better to go to a swapping station and get it swapped, right? So that while the technology is great, it needs to be put into the appropriate usage based of the type of scenario which you are in, whether it is in rural or whether it is in urban. Okay, so these are little projects. There are all kinds of projects that you can do. At the college level, you can look at, for street lighting, for home lighting in rural areas. Adopt a village, and do a hybrid solar wind project. Right? I think that will be great. Use simple technologies in terms of initial monitoring of your overall solution. How much energy is inbound? How much energy is consumed by the homes? How efficiently your battery backup system is working, what additional, are there any anomalies or problems in the system that you can notify the operator about. So it's a great learning experience. So I would encourage students and faculty to work together towards this. Okay. And eventually to scale it up to a simple small electric vehicle project. If you can get a rickshaw, electric rickshaw, maybe one of these Mahindra chargeable rickshaws or one of these electric scooters and so on, or scooties, right? Build a charging unit. Ravi, I'm sure would have talked to you about that. Build a charging unit, but integrated with a solar microgrid. Okay, and so that it's a useful case study and a useful reference point for how both these technologies can be combined together. The same is true for biogas, right? This is also a clean energy solution, easily prototypable. I think mechanical, chemical students can definitely contribute a lot here. Because this is definitely viable. There are different efficiencies which can come about, different types of designs based off how much of gas you want to generate. So there's a lot to learn here. I think this is somewhat underrated or understated, but I think is one of the most useful technologies, right? So there's so many other technologies. So many of you may ask me, well, what about the rest of things? Wind power, wave power, carbon capture and all that. Carbon capture, I personally, I am not for it. There's a lot of talk about carbon capture. Carbon capture, in my opinion, is it's like hiding your guilt underground, right? It does not encourage you to consume less. It does not encourage you to think about true renewable. Carbon capture is just capturing all this excess harmful greenhouse gases and trying to store it in rock formations underground, right? That's why I equate it to kind of hiding the guilt. And nobody knows how much energy is also needed in carbon capture projects, right? They don't come for free. And what is powering them, right? Is it really of any net benefit or not? So whenever you think of projects, think of it holistically. How much energy is required to build this technology? What is powering that technology? Is it fossil fuel or can it be done by renewable? How much energy output are we getting from this renewable source? At the end of the life, how do I recycle it so that it's not harmful for the environment? The net goal has to be very clear. How do I address energy imbalance? How do I preserve the environment, of which we are one part? These are the two things. Right? Everything has to be holistically taught based on that, not just one small piece. Okay. All right. So with this, let me very quickly move to. I'll spend maybe 10 minutes, and then I'll open it up for questions because I'm already running short on time. Okay. So let me talk a little bit about charging and swapping stations. Okay, so just use this picture. Okay, leave the rest of the company details and all that. This is a slide which is available on SlideShare. It's also was a presentation I made to IEEE about 2 years ago, right? While I was at a previous startup. So net, right? Now, because I'm not, I'm more specifically addressing the CS and EE students right now. Not to exclude the others, but this is a little more focused towards that, right? So there are four components here they need to look at, right, in a electric mobility solution, which involves batteries, right? There's a smart battery. So what do I mean by a smart battery? A smart battery basically has the chemistry and physics related to electric power creation, right, due to the chemistry of the process. But it also has onboard electronics to ensure uniform power output and generation, as well as safety and monitoring aspects, right? So that is what essentially constitutes a smart battery. Now, the smart battery can be used in essentially the battery, whichever solution you use it in needs to be charged, right? So you'll always need a charging station. On top of that, you can also have what are known as swapping stations, what I mentioned to you earlier. Okay, so the essential components are: you have a vehicle, you have a smart battery, you have a charging platform. It could be a charging point in your house, it could be a charging station, come swapping station like what I showed you earlier. Right? It could be any one of those. And the third piece is you now need software and monitoring infrastructure which looks holistically across your entire environment to monitor it, to configure all these things, to make sure that things are operating safely, and so on and so forth, right? Because these are all high power equipment. Swap and charge stations could anywhere be in the order of 30 kilowatt hour. Okay, electric buses, a large swap cum charge station could easily be a megawatt plus. Okay, so these are very high power devices, right? And safety is very important. And what are the different aspects of safety? Batteries are very sensitive, right, related to thermal. I'm sure Ravi would have talked to you about it. Thermal characteristics for a battery are very important. When do you charge it? You have to cool it down before charging. You have to monitor every single voltage of every single cell which is part of your battery, right? A battery pack comprises of numerous cells, right? Those cells all have to be reasonably healthy and within the same voltage parameters of each other, right? How do you monitor for anomalies in the battery, right? Others that can lead to short circuit. And lithium ion is notorious for runaway and thermal fires, right? How do you monitor the safety of that? In swapping and charging stations, you have to monitor safety, electrical power safety in terms of electric power leakage, the input voltage coming in, right? The quality and power factor related to that. Then comes the thermal safety of the station itself, fire detectors, smoke detectors, fire suppression, electronic fire suppression equipment. Then comes the cooling, right? Because the batteries have to be cool. You cannot, it's very ill advised to charge a hot battery. Batteries have to be cooled so that their life cycle is maintained and safety is also maintained. So you have to run HVAC systems. What are the algorithms you're going to run to optimally cool this entire station, right? So there's a lot of software and design which has to go, hardware and software design which has to go into smart batteries, swap and charge stations. And when you put everything together, right, you want the ease of use like Amazon solution, right, where you can sign up for, with a battery swap vendor, you can take your vehicle, get batteries, you can go anywhere, get charged, you can get billed easily, right? You can figure out by logging into a website how efficient your vehicle is working. This is especially true for large electric vehicle users like for buses and so on, right? Because they want, yes.
Sir, actually, we are stuck with slide number 23, sir. Energy Kickstarter project.
Oh, I wish you had told me that. Okay, let me stop sharing and share again. Yeah, I was explaining this picture actually.
Yes, sir. Yeah.
Okay. All right. Let me quickly summarize this. So I hope the concept. I don't know why I keep getting muted. Is some each time a slide is changing, it's getting muted.
Sir, if you don't mind, can you share your PPT so that I will be sharing? If you don't mind.
Yeah. I actually, interest of time, I'll be happy. I should have done that earlier. But let me just tell me, very quickly whether you can hear me or not, or if the slide is correctly. Can you hear me?
Yes, sir. We can able to hear.
Hello.
Yeah, sir. We can able to hear you, but we are not getting your presentation slide, sir. Hello, sir. Hello, sir. Can you able to re-log in, sir, if you don't mind, using the link again? Hello. Due to some technical glitch, Narayan sir has rejoined.
Hello. Can you hear me?
Yes, sir. We can able to hear you.
Yeah. Actually, this thing keeps muting each time I change the slides. I don't know how to manage that. Okay. Can you see my slides, please?
Yes, sir. We can able to see your.
You can see the slide?
Yes, sir. Okay.
So where do you want me to restart from? Because I don't know where you lost me.
So the smart battery and swap charge station, you were able to explain that concept, sir.
Okay, so let me rewind back then. Okay.
Yes.
So for every this electric mobility solution, right? There is always the smart battery, right? And the smart battery is composed of not just the physics and chemistry of generating electric power, right? All the chemical constituents, solid or liquid, thereof. It also comprises of a number of electronic stuff, right? So I'm sure Ravi would have explained to you about BMS, battery management systems, about telemetry and monitoring systems, and so on. Okay. So those are what constitute a smart battery. So the smart battery goes into an electric vehicle. Now the electric vehicle has a placeholder for this battery to connect and provide power, and it as an electric powertrain comprising of motors. Okay. Now, for all these solutions, you need to be able to charge the battery. Now, it could be a charging point in your house, or it could be a charging point in common charging stations, or it could be a battery swap solution where the charging station also allows you to swap batteries, whichever way it is. Okay. Now, in all of these pieces, whether it is vehicle, whether it is battery, whether it is station, all of them deal with significant power. Okay. Now, lithium ion, yes, for small two-wheeler, three-wheeler, the power is maybe 2 kilowatt-hour or so on, total energy capacity, right? So not a big deal, but still safety is important, right? Because lithium-ion batteries have to be treated carefully with respect to usage, with respect to when they get charged, with respect to the characteristics, they need to be sufficiently cooled before they can be charged, right? From a safety perspective, they are not to be used in very low temperatures because then efficiency goes low. And then there are certain other electrochemical properties that come in which causes danger. So there are so many factors which go into making a good high quality electric vehicle, right? It is not just like taking some battery and throwing it and connecting two wires and making it run. It may work initially, but then you will get later on into life cycle and safety related issues. Now, the same is true for charging stations or swapping stations, right? Usually they are dealing with many tens of batteries put together. The power requirement for these stations could be anything from 30 kilowatt hour for two-wheeler battery stations where there are 10, 20 batteries to electric bus stations could easily be in the order of megawatts, right? Depending on number of simultaneous buses which are getting charged, right? So these are very high power devices. So there's high voltage security needed, plus thermal characteristics also needed, right? Understand the bus is carrying 40, 50 people, right? And lithium ion charge bus has to have very good onboard electronics to ensure the safety of the passengers, to make sure that all the cell voltages are uniform, to check if there's anomaly in thermal rise in any one of the cells, right? For fire suppression, for smoke detection. This is true for batteries as well as these stations, right? Now, putting all this together in an Amazon type ease of use environment, right? Or a Flipkart type ease of use environment where you can onboard your vehicle, right? Where you can pay for your vehicle, the charge energy, consumed per month or per cycle, where you can get a report on how well, how efficiently your vehicle is performing. All this is where the network comes into the picture. A cloud environment comes into the picture, right? And then there are enormous opportunities for machine learning over here, right? Based on different characteristics and types of batteries and the profile of batteries, right? How the swap and charge station should efficiently operate, what time of hours of the day, can part of the station be shut down during night time based on usage pattern in a particular area, or based of usage pattern of types of vehicles that come there, right? How much of power is drawn, even useful studies on the power efficiency of the station itself, right? How good is your power factor, right? Can any improvements be done there? What are the different components which are impacting that? So there are so many hundred things for which software is needed, right? And a lot of this is what is computed at the edge, where close towards the battery or close towards the vehicle or close towards the charging station, where the cloud platform is used to collect all this data, do advanced learning, to do reporting, to get an overall view of the operations of this entire network of charging stations and this entire network of vehicles which are running around with these batteries. Okay. So what I want to convey is not just embedded technologies, it is edge computing technologies, it is cloud technologies. All of these are put together to provide a holistic solution. Let me move all this. Okay, so I'll just give you an example. Okay, very quick example. This is like a charging and swapping station. So there are various software pieces which are over here. One on the left hand side is a software stack layer to model and abstract out sensors. There's so many different types of sensors. These are things that I actually worked on, right? Humidity sensors, air pressure sensors, smoke sensors, thermal sensors, then normal sensors for detecting if the station any maintenance door is open, or if when you are removing a battery, if the door that opens it to deliver to you a battery, if that is opened or closed, because all that impacts safety as well as thermal characteristics, right? So the huge variety of station sensors which are needed. And when the battery comes in and communicates with the station, it is usually over CAN or BLE or potentially even over Wi-Fi, right? So there's so many interfaces that come in, and they all need to be modeled and handled correctly, right? And your core of your application stack from a software perspective is related to providing all the services, software services in the station or in the cloud, right, related to operating an electric vehicle fleet, right? It could be charging and swapping, the user experience, the UI which you will see. So please go to this website of Sun Mobility. You'll get great demos on products that I helped develop on which show how this entire experience is, right? Station monitoring, energy and thermal safety, diagnostics. If something goes wrong, what is the software needed to diagnose that based on all the data you have collected? Now, every time your embedded software has to change, how do we manage that? Right? Then there are the data collection and analytics pieces, so many pieces of things. And there are so many databases which are also needed. Some of them are time series, some of them are more traditional, relational database. Some of them could even be NoSQL, right? So all of this, believe it or not, is put even at the edge in charging stations, apart from being in the cloud, right? And IoT is the technology used. IoT consists of many protocols, right? The most popular one being MQTT, right? And it provides a publish-subscribe model for transporting all this telemetry, right? So this is very high-level pictorial view. I can spend easily an hour or two describing the details, but we're pretty much very short on time. I've actually run over time. And when you look from software, right, especially to the CS and EE students who dabble a lot in software, this is all the stack that you get to use, right? So it's not just embedded software and C. Yes, C, C++ is important, real-time operating system important from the battery standpoint. But from the charging station standpoint, Linux, running Docker containers, right, where image upgrades are made simple, different features are delivered via small containers, having messaging systems like Kafka or NATS, having Elastic and Grafana to troubleshoot and diagnose for charting and search and troubleshooting, and having this DevOps paradigm, right? Hopefully you'll learn about it in your CS courses, right? How to write software and how to design software so that it operates end to end. And this is a paradigm which has come especially from cloud related technologies, right? So this is a typical software stack. So I will stop here. I think because of time and other reasons, I will stop here and be happy to take any questions. So I hope this. So net, I wanted to summarize one thing, right? So when we talk about clean energy, it's a very vast area, right? What I really want you to take away from the slide is why is it that we are looking at clean energy in the first place? What is the motivating factor? What is our responsibility as engineers and technologists in this space, right? We have to look at it holistically. Right? Then you can get into understanding why solar and wind and certain things make more sense, right? If you understand what we should not be doing from emitting more greenhouse gases and so on. Even in that, the end-to-end life cycle is important. Okay, it is not enough to say I will have battery-based solutions, but everything is powered by coal-powered plants. That doesn't help anybody, right? We're just moving the problem from A to B. That's all that we're doing. You have to look at solutions where everything is renewable, powered by renewable sources, right? And net, what is the most important thing is while as technology students you look at solving these problems, electric mobility is one of them. Mass transportation is important to get people to use less fossil fuel vehicles. Encourage people to use public transport. That's why I'm not so much of a big fan of cars, because there are a lot of resources needed to make cars and vehicles and so on and so forth. What is the net return on energy? Somebody has to evaluate. Enough study hasn't been done, right? Whereas mass transit, I think it is a very logical use case. Right? When you get into the software and spaces, there are huge opportunities for how well you write software, be it for smart batteries, charging stations, network monitoring from cloud infrastructure platforms, making things efficient and optimized. Use machine learning for those purposes, right? In making sure that efficiency is squeezed out and it's optimal. Right? And finally, after saying all of these things, one thing I wanted to end in saying is that, all this is fine. Technology can only help up to an extent. The first problem that I mentioned to you was growing population and growing energy needs, right? Why as the population grows, and I talked to you about this energy imbalance, whatever that we do, whatever solutions that you develop here, makes sense if the per capita energy consumption starts coming down. Simple math, right? If there's energy imbalance, you are generating so much of energy at this point of time. If the per capita consumption does not go down in an increasing population, the energy imbalance is only going to get worse. Okay, which means that we are going to face more challenges. So as young students and technologists, please keep this in mind. Whatever that you develop, look at it holistically and also look at it from a per capita energy consumption for an ever increasing population of this planet. So I wish you all the best. I hope you got some value out of this. Happy to take some questions.
Thank you, sir. Thank you for your insights about climate change, as well as how our environment needs engineers to work on it based on the climatic changes, based on the ozone effects, and electric mobility also. So your information will be added for our students. Sir, now I request students who are having any queries, so you can raise your hands so that I can make you unmute and you can ask the questions. Or what best I can do is I can make you, the chat box is enabled, you can post your questions there.
Yes, please do.
Yes. I have enabled the chat box now. The students can post your question in the chat box.
Yes. And my apologies that, in and out I kept going out. I'm sorry. I hope you were able to get most of it.
Yeah, sir. We do have got a lot of insights about electric mobility, and we look forward to associate to you in long run also, sir, regarding this concept.
No problem. Yeah. Any questions, please?
Sir, actually, the same session has been streamed in YouTube also, sir. So there are a couple of questions has been raised from our student.
Okay.
Who could not able to join through this semester. So the one student has inquired about, is ozone hole causing climate change?
No, not really. Okay. So ozone hole causes other challenges, right? Because of UV radiation impinging on the earth, and by and large we have addressed that problem because of reduction of aerosols which release in the breakdown of the ozone layer. But ozone layer on its own has not caused climate change. It's caused some health issues, right? Higher incidence of cancer and so on. But in terms of net radiation, no. It's not the primary cause for greenhouse gas warming.
Yes, sir. Sir, another couple of questions raised in YouTube chat box. I would like to bring it to your notice.
Sure.
Sir, we know that greenhouse gas and temperature levels were distinct past.
Yes.
Sir, hello? I will repeat the question.
Yeah.
Sir, how do we know that greenhouse gases and their temperature levels were in distinct past regions.
Oh, how do we know?
How do we know
Yeah, sure,
greenhouse gas, their
Yeah.
existence and temperature levels?
Okay, so good question. So there are a couple of ways in which scientists have done this. I actually know somebody who has done this work. There are a couple of ways in which people study this, right? One is to go into the Arctic and Antarctic and highly glaciated regions of the world, and they drill. Now the question is, why do they drill? Right? They drill ice cores, which many hundreds of meters or a couple of thousand meters deep, right? And they extract huge pipes of ice. That ice has formed over thousands of years, right? And they contain trapped gases. Okay, so based of the geology of that area, they will be able to find out the date of that particular period of ice. Then also with the trapped gases inside, they'll be able to determine what is a percentage, proportion of different types of gases in the trapped air which is there inside the ice cores, right? So that is one way of correlation. The second way of correlation is also a strong correlation between temperature of oceans and the isotopes of oxygen. Okay, so oxygen has 16 isotope and 18 isotope, right? And depending on the proportion of those isotopes, there is a variation between what is there in sea, and because of what is there in sea, what is there in the carbonate shells of sea animals which are dead, versus what is there which has evaporated and fallen, rain, and become glaciers and ice on the surface today. There are different proportions, and then there are different studies which show how the temperature varies in correlation to these isotopes of oxygen. This is how people have historically built it up. There's a huge science around this. So I'm happy to share you some links where you can go through them.
Thank you, sir. Thank you for your valuable insights about the question asked by a person student. Sir, there is one more question which has been raised.
Yes.
What happens if the next solar and green energy becomes less active? Whether it will affect our climate and environmental issues will be boomed again?
So I didn't understand the question. What happens if solar?
So what happens if solar, wind, and other green energies will be becomes less active? Whether it will affect our environment in large run, or whether we will be facing the energy crisis?
Yeah. So this is the interesting question, right? So today we have certain proportion of our power is generated from renewable energy, right? Be it from solar, be it from wind, and so on, right? Now, or be it even from nuclear. I mean, that's one thing that I didn't talk about. I talk about it in my longer talk. I think that's a very viable thing for us to look at, but let's leave that on the side for now. So let's look at solar and wind. Right? Now, the question in front of us is very simple. Okay, we can either continue on our current path today, that is using primarily fossil fuels and having some proportion of renewable energy. What will happen in that consequence is that our greenhouse gas emission will keep going up. And you remember that spectral graph and that thermal chart which I showed you, the balance of energy in and energy out, right? That's only going to get worse. And as the planet warms, I gave you some explanation about thermohaline cycle, about droughts, about diseases, about sea level rise. So all those impacts are going to get worse. Now we have only one choice. Okay, we have only two choices in this. One is to reduce our per capita energy consumption, right? As I mentioned at the end. Okay, but even that is not enough because we are only delaying the problem. See, by instead of emitting couple of kilos of carbon dioxide per month, if I emit half of that, I'm only delaying the problem, right? The carbon dioxide is still accumulating. Please understand that. I'm only delaying the problem. Or two, I make all efforts to switch towards renewable energy, right? And so that the net carbon outflow is zero or negative, right? Preferably zero, right? I don't know how it'll be negative, but preferably zero. So That is the focus for this. The focus is how do I fix this energy imbalance so that we are back to a level that nature can work and absorb. We are now at a level that nature can no longer absorb, and hence all this stuff is getting into our atmosphere and we are having unnatural warming, right? That is the net effect. And coincided with that is while we are making this transition, we have to, it is my firm belief, we have no choice. We just have to reduce per capita consumption. Okay. And how we do that is up to each one of us. Please understand, we live in a very unequal world today. Even in India, okay, people in Bangalore consume on average a lot more electricity than somebody sitting in a small village in North Karnataka. Then forget rich people, very rich people in India have huge houses, many stories high, consuming so much more power than the average house in India. Right? We all know who they are. Then look at worldwide. The average person in United States consumes between 9 to 12 times more energy than the average person in India. Now you can complain, somebody complained today in presidential debate that India is a dirty and filthy country and we have dirty air and all that. We have a huge population, 1.4 billion people. United States is only 300 million, right? But the total energy consumed by them is 12 times more than what we have. Right? Not 12 times. I'm sorry, it's about a double. Okay, but they have only 1/4 of our population. Okay, so there is obviously an imbalance. We cannot solve this problem, okay, unless everybody gets together and acts responsibly and reduces per capita consumption and makes it equitable. It has to be equal. Why should somebody in a small village suffer and subsidize somebody in a big city who's enjoying all this power and electricity? It is not fair, right? So that is why I want to emphasize this need for, when you do your economics course, to look at and handle and discuss and debate all these issues, right? It is super important to have an empathetic, compassionate, and humanitarian viewpoint around this entire green and clean energy technology base. Okay, it's not just about technology. Yes, sir. More questions.
Sir, actually, that is the end of the question. That's the last question I have taken. And one more question the student has given about, can you give a few office where the solar rooftop...
Yes, I lost you for a minute. Can you please repeat?
Sir, one student has asked about, can you give best examples where the rooftop, where the solar panels have been implemented in corporate sectors?
Actually, I am not very aware of how it has been implemented in corporate sectors. I've heard of some stories of, some of the tech parks in Bangalore, one or two of them making good initiatives related to, solar rooftop. But I personally have not seen it. I cannot comment. Okay. There are organizations like C-STEP. If you go CSTEP, if you go, they have a nice website and I have an application which shows the optimal. They have recently released a product where for even households or larger buildings, what is the optimal location of solar rooftop panels based off your vegetation and trees around you and your location and so on and so forth, right? Because you have to be, like you need to have that south facing and all that, right? So that you have equitable distribution. And based on other buildings around you, if a lot of shadow falls, then is not very efficient. So there are companies who have worked on some very nice solutions around that. But I personally am not aware of, I don't have enough know-how. I assume that some of the large companies in India, in their private cities and so on, probably have significant solar farms, but I do not. I personally have not seen, I don't know. Okay. But I certainly recommend it, right? I certainly recommend that. I think it's a good thing to do. Good thing for number of homes also to have solar panels, not just for hot water. If you are able to afford it, even to give energy back to the grid or to use it for your storage purposes.
Okay, sir. We have come to the end of the webinar series.
Sure.
So now, yeah, sir. Thank you for your insights about climate change, environmental sustainability, and rural development, and about insights about electric mobility and electric vehicle. So the session was beautifully narrated from your side, sir. I hope the student have gained enough knowledge regarding all three aspects. So now I request Rajesh KS to render vote of thanks.
Thank you, sir.
Thank you.
Good evening to one and all. ATME CE has emerged as a prominent institute offering quality engineering education. It is a great initiative by ATME IEEE student branch to organize the webinar series. I, Rajesh KS, Assistant Professor, take this opportunity to render vote of thanks. I thank Mr. Narayanan Subramaniam, mentor and public speaker, for sharing his resourceful insights on sustainable environment, electric mobility, and smart pad. Thank you, sir. I thank management of ATME CE for constantly encouraging us and supporting in organizing this webinar. I thank our beloved principal, Dr. L. Basuraj, for his valuable guidance in his conduction of this event. Thank you, sir. I thank Dean Research, Dr. S.R. Bhageshri, whose efforts have paved way for the successful conduction of this event. Thank you, ma'am. I thank Dean Academics, Dr. M.S. Govindagowda, and Dean Student Affairs, Dr. Ratnakar Ji, for their support. I am thankful to the enormous efforts of the IEEE Student Branch Counselor, ATME CE, Dr. Parthasarathy L, for the valuable guidance throughout the conduction of this event. I extend my gratitude to the heads of various departments for extending their sincere support. I thank organizing committee for providing students with an opportunity to explore on the concurrent technology. I thank all the student participants of ATME CE who have joined us. Thank you all.
Thank you very much for having me over. I hope you found it useful, and any questions, you can always feel free to reach me on LinkedIn. It's easy to find me.
Yes, sir. Thank you. I hope our students will be in touch with you in LinkedIn platform. So I request students to submit the feedback which has been depicted in chat box. Thank you, sir. Thank you for your valuable insights.
Thank you for having me over.
Yes.
Have a happy Navratri to everybody, and please stay safe.
Yes, sir. Thank you, sir. Thank you. We look forward to associate in long run, sir. Thank you.
So, thank you very much.